Hi, George Williams, founder and CEO of Reliability X, and as a follow-up to our previous video on what is predictive maintenance, today we're going to talk a little bit about why we utilize those technologies for condition monitoring. What's the purpose behind all of that? Well, when we think about the PF curve and the maintenance sawtooth and the bathtub curve and all these other things that exist to help explain various maintenance and reliability techniques, let's take a look at how that kind of comes together with respect to predictive maintenance. So, from a predictive maintenance perspective, we've got our typical base condition of the asset. This is how the asset was shipped, delivered, installed properly, and our expected reliability of the asset. Throughout the asset's life cycle, the asset will deteriorate over time. It will create friction in bearings that need lubrication, and then our amp readings go up, and lots of other ways that we deteriorate. We deteriorate wear components and lots of other stuff. And so we get this deterioration, and then maintenance shows up and either takes an intervention or executes a preventive maintenance activity and restores us back to base condition. This happens over and over and over again. In addition to restoring back to base condition, we assess the condition of the asset throughout its life. We utilize techniques like the use of vibration analysis and oil analysis and infrared thermography to, during that life cycle, test and assess condition of the asset. At some point in time, we'll find out that this particular bearing has a defect and is going to foul eventually. It has not fouled yet. It may be not hot to the touch. It may not be making noise, but our indicators are that this bearing is going to foul. That's what these technologies are for, to tell us we have an imminent failure. Why do we care about knowing an imminent failure? Well, we would like to have minimal impact to operations. And so knowing this ahead of time gives us a maximum planning time to plan the intervention when it is most convenient for the operation. It's not always convenient. However, when it's most convenient, I now have time to order the proper materials, get them ready and staged, work with production or operations around when can I get the asset, when it's most convenient. And even if they tell you you cannot, you at least have all the parts ready to go, and it becomes a NASCAR swap out when it's ready to, when it finally happens. So we utilize these technologies to give us a bigger window than our senses. That's really the purpose behind the use of these technologies. And so if we're using these technologies and identifying failures, but then not planning the activity when it's convenient for the operation, we're kind of wasting our money and missing the point. So we want to do all these things so that we can maximize planning window. The other major advantage to utilizing those technologies is minimizing catastrophic component failures outside of the initial failure. So for example, if I have a bearing that's about to fail, my predictive technologies don't pick it up, or I'm not using those technologies, and I don't know that that bearing's going to fail, when it finally fails, I may score the shaft. I may ruin a pillow block. I may have ancillary damage to other components that would not have been impacted if I was using predictive maintenance and replaced the part before the other damage. So what does that do? That reduces my overall maintenance cost. If today you're not using these technologies and you have an incident, your costs go up because of the ancillary damage. In the future, when you use these technologies, you don't have that extra ancillary damage that currently you're having ongoing and ongoing and ongoing. And so, through the use of predictive technologies, we get to find lots and lots of fantastic finds and get rid of problems before they become a catastrophic nightmare. So, we want to know impending failure early. We want to maximize that planning time. We want to minimize an impact to operations. We also use these techniques for root cause analysis and continuous improvement purposes. For more information, go to www.reliabilityx.com or email us at ask@reliabilityx.com. Don't forget to hit subscribe and like. We'll see you next time.